Assalamualaikum warahmatullahi wabarakatuh. So today I will explain about my progress on final project on numerical class method. So let's begin. So I will start with aerodynamic force. So aerodynamic force is the force that appears when an object passes through the fluid. For this case, we assume that the fluid is air. That transfer in the perspective. So the fluid, the object is basically passed through the air, but in the perspective of the object, the fluid is relatively passed through the object. It's like a relative motion of a common object. This force is emerged as a consequence of the solid to fluid interface. It caused the alteration of pressure, we can say static and dynamic pressure, around the solid body. So we can see in this figure that aerodynamic force is not as Fa. We can describe this force into two different ways. The first one is normal and axial force, denoted by N and T. And then the second term is lift and drag force, L and T. We can see that the uh, resultant of these two nomenclature is exactly at Fa. All of this force is acting on Cp, center of pressure. The Cp is located in the distance L to Cm, or we also say that Cm is center of gravity, or Cg. First term is normal force and axial force. Normal force is the force that perpendicular to the surface of the plane, and the axial force is the direction is parallel to the normal or the surface dA. The second term is lift and drag. Lift is a force that acting on the direction perpendicular to the arrival of the fluid, or we can say that the lift is perpendicular to the relative wind, which it is where the fluid or air coming. Then drag is the force that is parallel to the direction of the arrival of the fluid. So basically, the difference between two terms above only lies on the reference axis, where the normal and axial force take the object axis as the reference. Then the lift and drag force take the direction of the fluid or relative wind as the reference. So the aerodynamic force can be written or usually expressed in the form of dimensionless number, namely Cln, or coefficient of lift, and Cd, coefficient of drag. So basically these two dimensionless number is the force divided by pressure drag, where the L is a total lift force acting on a solid body, and then drag force is the same, the total drag that acting on the object. Rho is specific air density. Rho in this case is air density, because this is aerodynamic analysis. So the fluid is we can ensure that the fluid is air. Then S is the projection area of the object. We can see that in this figure, the normal we can transform lift and drag force from the normal and uh, axial component force by transforming into transforming or specifically by rotating the force by the angle of attack or alpha. So the given that the force is a vector, so the value of CL and CD can be positive or negative. The positive sign means that the force is in the same direction as the standard Cartesian basis, and the negative means that the force is opposite to the standard Cartesian basis. So if we encounter with the negative sign, it not it it doesn't mean that the value of smaller than zero, but it means that the direction is uh, the opposite direction to the uh, basis of the vector. So the value of CL and CD is a function of angle of attack, or we can say that the direction of air, and the velocity function, which is represented in the form of dimensionless number, dimensionless number called Mach number. The expected value of CL and CD at the different flying condition will certainly be different. Some of flying condition included the first one is launch. So in launch mode, it is expected that there is no force or as close to as close to zero value acting on the missile, so that there is no moment against the center of gravity, which can dangerous because it can reverse and goes back to attack us. Then the second flying condition is cruise. When cruise condition, the lift is expected to be able to compensate for the gravity of the missile itself. On the maneuver, in the maneuvering condition, the lifting force is able to oppose gravity so that a moment occur about the center of gravity, and finally the missile direction can rotate, or we can say it pitch down or pitch up in two-dimensional. The objective of this project is first, evaluate appropriate angle of attack with a maximum and minimum of CL at the given Mach number. Second one is evaluate appropriate angle of attack with a maximum and minimum of CD at a given Mach number. Then three is determine optimum angle of attack to generate lift over the minimum drag. So we will use two types of optimization scheme. First one is the easy one, graphical solution, by plotting the data and approximate the uh, proper the behavior of the data to some function, and then we can evaluate where the maximum or minimum number of a given dataset. Then the second one is the golden search ratio, the golden section search. So it is a technique for finding the extremum. Extremum is included minimum or maximum of the function inside a specified interval. The the calculation algorithm is similar to bisection, but in bisection we divided the interval by by constants 2, but in this scheme we divide the interval by the golden number. uh, it will explain later. So We will utilize this method especially on drag coefficient because theoretically the drag coefficient is behave like a second polynomial. So we can find the minimum by this scheme. Golden search, we can say in this figure that it is bounded by xl, which is x lower, and then xu is x upper. We can notice that this this black dot is the local maximum of the function. So the first iteration will divide the interval by L1 and L2. And then the second iteration, after we obtain some new point, we also divided it by appropriate number. So L0 is equal to L1 plus L2. Assume that the comparison of the new interval and the comparison of the previous interval are the same. So L1 per L over L2, L0 is equal to L2 over L1. We can write as L1 over L1 plus L2 because L0 is basically L1 plus L2. Then we can introduce R as L2 over L1, then simplify, and we can we can obtain it is two polynomial. Then we can find the root of the polynomial is 0.61803 blah blah blah. So we introduce that d is equal to this coefficient 0.61 times x upper minus x lower. Then the x1, the first guess is x lower plus d, and x2 is x upper minus d. So this is basically a mathematical model to solve this kind of problem. So that's all for me for this week. And thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.